Fluid statics. It gives the idea of fluid at rest. It based on the pressure and its measurement on the fluid. Now, what is pressure? The applied force per unit area is called pressure. If a force F is uniformly distributed over a area A, then the pressure at any point is given by P equals to F by A, where F is applied force. The uniformly distribution of forces means the magnitude of forces at any point over a area is constant. Now question may come, what is the difference between pressure and stress? Pressure is the applied force per unit area and stress is the resistance force per unit area. In case of rigid body, F equals to R, because under the application of the applied force, this body does not deform. Hence, pressure equals to stress in this case. But in case of deformable body, such as semi-solid, F is not equals to R, because under the application of applied force, the body gets deformed, and hence pressure is not equals to stress in this case. Now, unit of pressure. In CGS, it is dyne per centimeter square. In SI and MKS, it is Newton per meter square, which is called Pascal. And another unit is bar. 1 bar equals to 100 kPa, and this equals to 10 to the power 5 Newton per meter square. Let's go to the Pascal's law. It states that the pressure or intensity of pressure at a point in a static fluid is equal in all directions, where intensity of pressure means the pressure at certain or unit area. In case of fluid, the pressure is also called intensity of pressure. Let's go to prove the Pascal's law. Consider an arbitrary fluid element as wedge shape of dimension dx, dy, ds in a fluid mass at rest as shown in figure, where arbitrary means irregular shape. Let the width of the element perpendicular to the plane of the paper is unity. That means the width is along z direction equals to 1 unit, which is unable to shown. Now Px, Py and Ps are the pressure or intensity of pressure acting on the face AB, BC and AC respectively. You know the pressure having no direction, only force have direction. Therefore, Px dy into 1, Py dx into 1 and Ps ds into 1 are the force acting on the face AB, BC and AC respectively, where dy1, dx1 and ds1 are the area on the face AB, BC, AC respectively. Let angle ACB equals to theta. As the fluid element is under equilibrium, the summation of Fx equals to 0, or Px dy into 1 minus Ps ds into 1 sin theta equals to 0, where Ps ds into 1 sin theta is the component of Ps ds 1 in x direction, or Ps dy minus Ps ds sin theta equals to 0, or Px dy minus Ps dy equals to 0 as ds sin theta equals to dy, or Px equals to Ps, which is the equation number 1. Similarly, summation of Fy equals to 0. If Ps ds 1 cos theta is the component of Ps ds 1, then Px dx cos theta plus half into dx dy into rho g minus Py Px into 1 equals to 0, or Px dx plus 0 minus Py dx equals to 0, as ds cos theta equals to dx and dx dy is very small equals to 0, or Px equals to Py, which is the equation number 2. Therefore, from equation number 1 and 2, we get Px equals to Py equals to Ps. which represent the Pascal's law. A point to be noted that the weight of the element is mass into g, as the mass equals to volume into rho and the volume equals to area of the triangle into 1, which is equals to half dx dy into 1, where half dx dy is the area of the triangle. The weight equals to volume into rho into g, and this equals to half dx dy into 1 into rho into g, which is shown in this figure. Now, hydrostatic law. It states that the rate of increase of pressure in a vertical downward direction must be equal to the specific weight of the fluid at the point. It means if we go downward in a fluid with a distance, then the change of pressure with respect to distance is equals to the specific weight of the fluid. Now go to prove the hydrostatic law. Consider a small fluid element as shown in figure. Let delta A is the cross-section area of the element. Del Z is height of the fluid element. P is the pressure on face AB. Z is the distance of fluid element from the free surface. The forces acting on the fluid element are pressure force P into delta A and acting perpendicular to the face AB in the downward direction. Pressure force P plus dP into dA acting perpendicular to the face CD in vertical upward direction. Because P is the pressure at the face AB and dP is the change of pressure from B to C. So total pressure at CD is P plus dP. Weight of the fluid element equals to volume into rho g equals to dA into dz into rho g. Thus, PdA minus P plus dP dA plus dA into dz rho g equals to 0, or minus dP dA plus dA dz rho g equals to 0, or dP by dz equals to rho g equals to small w. This is the fundamental equation of fluid static, represent the hydrostatic law. Now, by integrating the above equation, we get integration dP equals to rho g integration dz, or P equals to rho g z. In general case, z is represented by h. So, the equation become P equals to rho g h. P is the pressure above the atmospheric pressure, and h, which is called pressure head, is the height of the point from the free surface of the liquid. Let's go to know the principle of hydraulic press. Let's see the picture of hydraulic press having ram and plunger system. This system is used to lift a heavy weight in ram by the application of lower force in plunger as shown in figure. According to the Pascal's law, the intensity of pressure will be equally transmitted in all the directions. Hence, the pressure intensity at ram is equal to the pressure intensity in plunger. If capital A and small a are the area of ram and plunger respectively, then F by A equals to capital W by A, or F equals to small a by capital A into W, where F is the applied force on the plunger and W is the weight which is to be lifted on the ram. As area of plunger is less than the area of ram, F is less than W. That means if a small force is applied on the plunger, a bigger weight can be lifted on the ram.